Good day everyone. In this coming SPM, when you are sitting for your MX paper 2, section C, you're required to answer 2 out of 4 questions. Among the topic of solution of triangles, index number, motion on a straight line, and also linear programming. Now, how many of you have decided not to go for the topic of solution of triangles? Because we always have the mindset that the problem for this topic are always harder as compared to other 3 topics, right? But it's always good to have more options. So in these lessons, we will have an overview on the actual SPM questions for this topic, solution of triangles, from the year of 2010 to 2019. Let's have a look. And before that, a quick recap on this topic will be conducted. There will be a total of 3 formulas to be explained and also 2 concepts to be introduced. Let's have a look. There are a total of 3 formulas that we can apply to solve the problem for this topic, which are sine rule, cosine rule, and area of triangle. Before looking into the formula, when to apply and how to apply, let's have a look on this triangle. Okay, now in this triangle, you will realize that there are capital letter A, B, C. You also have small letter, so small letter A, B, C. So first you have to be clear that capital letter, it was used to represent what? The angle, right? And small letter go for the side of the triangle. Now this one must be clear. For instance, if this is your angle A, opposite of this angle, you have the side A, small letter, side A. And we can conclude this is as one pair. This is a one pair of angle and side. Okay. So same thing, likewise, if let's say this is angle B, opposites you have a side B, small letter. So this is how you label it, capital and small letter. Okay, clear. Now we have a look on sine rule. Sine rule, there are, as you can see, there are 2 formulas here, but actually they will derive from the same formula. Just the way of presenting it is different. So it's up to you which one you want to apply. Okay, let's say we have an example of the diagram. And you might ask, when do we use the sine rule? When you have at least one pair of angle and side of triangle. When you have one pair of angle and side of triangle, you can apply the sine rule. Okay, for example, let's say this is 35 degrees. You must have a pair of angle and side, right? So this one you will know, let's say it's given is 5 cm. So now you fulfill this criteria. You have a pair of angle and the side of the triangle. A pair, 35 and also 5 cm. And you're required to find the angle B, and you know that the side B is x cm. Okay, can we use the sine rule to find the angle B? Yes. Okay, so we will have sine B over which side? X cm. So you put x equals to another pair, sine 35 over 5. And what do we have? Okay, so to continue, to proceed to find the angle B, what do you need to do? Right, sine to sine inverse this is your answer. Okay, this is an example on how you apply the sine rule to solve the problem. Okay, and then now we look at the second formula, cosine rule. When do we use the cosine rule? It's very simple. When you cannot apply the sine rule, right? As simple as that. When you do not have a pair of angle and side of the triangle, you can try using cosine rule. So when you cannot apply the sine rule, you can try cosine rule. Or one of the case, very specific, when you have the three side of the triangle given to you, none of the angle you know, but you know three side of the triangle, and that would be cosine rule. Okay, of course I will give you an example. Okay, let's say we know this is oh no, we do not know angle, so this is 5. I just simply put this is 7.5, and you need to find the angle, this angle, this angle. Look at the formula. C squared equals to A squared plus B squared minus 2AB cos A. Oh, sorry. There's something wrong with the formula. My bad. It should be okay. If let's say you're looking for C squared, C squared equals to A squared plus B squared minus 2AB cos C. Now, so confusing. Which one is A, which one is B, which one is C? No idea, right? Okay. Now, in these situations, you are required to find this angle. You want to find this angle, right? Oh, sorry. You need to find this angle. Oh, no wonder. You need to find this angle. Right? So this is the angle that you need to find. Question mark. We don't know. So if this is the angle we need to find, that will be here. This one is considered angle C. Now please do not confuse with the letter. Okay, I want you to remember when you need to find this angle, this will be angle C based on the formula, and these two sides when you have this side and this side, you form this angle C, right? You will regard these two sides as AB, small letter A, small letter B. Okay, why? Because logically speaking, this one should be small letter C, opposite of the angle C. So by right, the two sides of the triangle surrounded by angle C, that will be A and B, definitely. Which one is A, which one is B is not important, as long as you know which one is A and B. So you put in, let's say this is A, this is B, and which one is your small letter C? XCM. Okay? Remember, how you remember, if let's say that is angle C, the two sides of the triangle is small letter AB. So, and the opposite will be small letter C. And you can find it by using the cosine rule. So I put in C squared, which is X squared. X squared equals to A squared, 7.5 squared, plus 5 squared minus 2 brackets cos C. Maybe, yeah, let's call it cos C in this case. And then, what is your next step? You have X squared minus 7.5 squared minus 5 squared, and then if you can see it, divided by negative 2 bracket 7.5 bracket 5 equals to cos C. Can or not? Here minus, and then you have this part. This is multiply. So you go here, you have divide. Okay, and let's see what we have. X squared minus 7.5. It will be negative, yes, divide by negative 2. Okay, beautiful answer. So you have 0.23 equals to cos C. And you know lah, to find it, you have to have shift cos. Okay, shift cos inverse. You have 76.70 degree. So this is 76.70 degree. There you go. This is how you apply cosine rule. When you cannot apply sine rule, you do not have one pair of angle and side of the triangle, you apply the cosine rule. Or one of the situation is when you have three sides of the triangle, you apply the cosine rule. You do not have any angle that you know. Okay, and the last one is the area of triangle. Now same thing, if you have 1 over 2 AB sine C. So, okay, look at this triangle. Okay, ignore the ABC written here. Maybe I draw a new triangle. Oh, it's okay. Okay. If let's say first thing that you have to look at is the angle. The first thing that you have to look at is your angle. So is there any angle that you know? Let's say you know about this angle. Okay, we call this angle C. We call this angle C. Then you have to find the side A and side B. And where is side A and side B? Remember what I have explained just now? If let's say that is angle C, side A and side B will be together, surrounded by angle C, right? So whenever you have these situations, you know this angle and you know the side of these two, then you can find the area. Okay, so let's say this is 35. I used the example just now. 35 degree. This is 7.5. This is 8. You put in, you have 1 over 2, 7.5, and also 8 and sine 35. That will give you the area of the triangle. Now this one is quite simple. You should have 17.21 cm squared. Okay, remember this is just a recap. So does it bring back your memories on sine rule, cosine rule, and area of triangle? Okay. Now, since you know about these three formula, there are two more things that I want to emphasize here. In this topic, this subtopic is really famous. Ambiguous case. Ambiguous case, ambiguous by words, it means unclear, not so sure. So ambiguous case is where you have two triangles that can be formed. Okay, when you have ambiguous case, you can have two triangles that can be formed. What does it mean? Okay, later on I will show you the example, the actual SPM MX questions. You can have a look and you will know what I'm trying to say. Okay, and the scenario would be, let's say you have these three informations. You have side A here, and say this is 5 cm, let's say. And you have also side C, and this is 7.5 cm. And your A must be lesser than C. 5 lesser than 7.5. Okay, this is the situation. And you have angle A as an acute angle. This one is an acute angle. Now, what is an acute angle? What is the range of the angle? Remember? From 0 to 90. Okay, quadrant 1. Well done. So if let's say this is an acute angle, for instance 35 degree, you have to, this is the situation, two triangles can be formed by using all these three informations. I will show you how. I will show you how. Okay, let me get my ruler. So when you have two triangles that can be formed, I will make sure this is still 7.5. I will make sure this is still 35. I will make sure this is still 5 cm. But I will form another point here. And I will call this as C prime. C prime. When you have prime, meaning you have a new, you have moved the points. It's a new point. It's an image from point C, and I will draw like this, so it will have a different shape. Now, does it still have the same information? Yes, because BC prime, it is still 5 cm. Okay, so I am sketching a different shape with the informations that BC prime, it is still equals to BC 5 cm, and this is still 7.5, nothing changes. This is still 35 degree. Is it possible? It is possible, and you can have two triangles in this diagram. The first triangle is over here. You have BA, BAC. This is your first triangle, and that is the shape. 7.5, 5 cm, and 35 degree. Okay. The new shape of the triangle, you have BAC prime, and the shape is different, but the information is the same. 7.5 for AB, 5 cm for BC prime, and also angle A 35 degree. It's still the same informations. It's just that it's a new triangle, different shapes, and you can have these two triangles formed in this context, and that would be the idea of ambiguous case. So in the actual SPM questions, later on I will show you some keywords that you can find to help you identify ambiguous case. This is the idea. Now let's have a look on the actual SPM questions to help you to identify ambiguous case. So the first thing here in these lessons I will talk about is ambiguous case. Why? Because in 2010s to 2015s, except for 2011, year 2011, in these 5 years, 2010 to 2015, except 2011, believe it or not, we have this context ambiguous case in every year. For the exam paper, MX paper 2, section C, ambiguous case for 5 years. Now, do you think it's important? Do you think that ambiguous case will be presented in this coming SPM? No one knows, but it's always good when you are ready for ambiguous case. Now let's have a look on how you solve the ambiguous case. I'll show you some keywords and help you to identify. Okay, now this is SPM 2010. The diagram shows a triangle ABC and triangle CDE, where BCE and ACD are straight lines. Okay. So you have part A and also part B. So I'm telling you that part B, this part is about ambiguous case. Okay. Before looking into ambiguous case, maybe it will be best if we can solve part A first, to see whether you are familiar with sine rule and cosine rule of area of triangle, since there are only 3 formulas to be applied for these topics. Look at part A, calculate the length in cm for BC. This is BC. Okay, whether to apply sine rule or not. When to apply sine rule? Remember, when you have a pair of respective angle and side, opposite angle and opposite side, and you look at triangle ABC, do we have the one pair of angle and sides? Yes, we do, right? 4 cm and 50. So yes, we can apply sine rule and BC and 25 degree. So you can have okay, 4 divided by sine 50 multiply, okay, you know this is multiply, right? 2.207, 4 significant figure, okay? 4 significant figure. So you have 2.207 cm. And done. A1. A2, find the length of DE. This is the length of DE. So we are looking into another triangle. CDE, CDE. Look at the triangle. What do you know? You know about the length, 6 cm, 2.5 cm, and the rest. This is all you know. So how? You know no angles, and you do not have much information. So if this is the case, always refer to another triangles. Always refer to another triangles. Okay? Okay. Now we look at this part. Green color triangle. You have 25 here. You have 50 here. Is it possible to find this one? Yes, but why do we need to find this one? This angle will be identical as this one, because when you have two intercepting lines, opposite angle are identical. They are the same value. Okay, so what do we have here? 180 minus 25 minus 50. So this would be 105 degree. Okay, and when you look at this triangle, yellow color, CDE, do you have a pair of angle and a side? No, right? You do not have that, right? So we are going to apply cosine rule. Cosine rule, Cosine rule, the most important part is you identify the angle C. Remember, cosine rule, you have C squared equals to A squared plus B squared minus 2AB sine C. Cos C. It's up to you whether you want to call it C or A. But there will be one angle that you can play around, and the only angle that we know here will be 105. So this is your angle C. If this is your angle C, this is your side C, and the other two will be A and B. Doesn't matter which one is A, which one is B. By putting this into informations, into the equations, C is ED, what you need to look for. So ED equals to square to the other side, square roots, right? A is 6. Okay, there you go. You should have 7.072 cm for significant figure. Okay, done. So A1 and A2 are done. Okay, so now we look at part B. Part B is about ambiguous case. And how do we know? I'm going to show you the keyword here. But before that, let me take it off. Okay, we put it on later. Okay, you have a sentence structure in this way, something like this. You have sentence structure like this way. Point C prime. Now, do you see? Not C, but C prime. So what does it mean when you have C prime? Prime stands for image, right? The image of C, meaning there is a new point called C prime. Transfer from C to C primes. Okay, there's this new point C prime. Lies on the line BE. Okay, where is BE? BE. This is line BE. And point C prime is along the line. We don't know where. It could be here. Oh, sorry, use different color. It could be here, C prime. Okay, it could be here, it could be here. Oh, sorry. Either one of them, we don't know where, but along the line. Okay, so what information do we know else? We know that AC prime equals to AC. Hey, what does it mean? AC prime equals to AC. AC prime, AC, they all share the same point, which is A. Okay, let's say this is A, this is C. We have something like this, AC. And equal. Equal meaning the length is the same. The length is the same. So what is the size for AC? 4 cm. Okay, you put it in. 4 cm. AC is about 4 cm. How about AC prime? AC prime equals to AC, and AC is 4 cm. Therefore, AC prime also 4 cm. Okay? AC 4 cm, AC prime 4 cm. Then wouldn't it be something like this? 4 cm, and this is C prime. And since C and C prime are on the same line, which is called line BE, right? Line BE, like the yellow color. Meaning, this is a what? What did you observe? This is a, what is this? What do you call this? Isosceles triangle. Am I right? This is an isosceles triangle. Okay, the first keyword here is, most of the ambiguous case, you have isosceles triangle. The first keyword, most of the case of most ambiguous case, you have isosceles triangle. Okay, so if let's say this is AC, so AC prime should be somewhere around here, C prime, so that I can form an isosceles triangle. Okay? Because you know that it is 4 cm for both of the sides. Okay, this is what you know. Okay, this is what you know, but this is not what you need to do. We look at B1, sketch triangle. Ambiguous case always come with sketching a new triangle or a new shape. It doesn't have to be a triangle. A new shape. Now we have sketch triangle AC prime B. Try to allocate these three coordinates, these 3 points. And this is A, this is C prime, and this is B. Okay, you need to sketch this triangle. Okay, now I'm sketching this. So the second keyword here is sketch. You have isosceles triangle, and you will see the keyword here, sketch. So this is the second keyword to tell you that this is an ambiguous case. So let's sketch it out. BC prime. Okay, so we have doesn't look like it, maybe something like this, Okay, something like this, right? And you also have here, this is AC. This is A, this is C, this is C prime, this is B, and what do you know? This angle never change, 50 degree. This is 4 cm, this 2. Okay, that's what you need to draw to sketch the triangle AC prime B. Okay, now comes to sketching. First you must have the shape as described. So this is the shapes, and also you have to label C prime here. You have to label C prime here and put in information that you know of that will not be changing. For example, 4 cm here, 50 degree here, these two will not be changing. So this is how you sketch the triangle AC prime B. Okay, afterwards look at the questions. Find angle AC prime B. Where is the angle? This is the angle. You need to find these ones. Okay, so in order to find this one, let's look at the diagram. Okay, we have to find this angle AC prime B, and you know that this is an isosceles triangle ACC prime, so this will be the same angle. Same, okay? And do we know about this angle? Right, just now we have found this angle, right? This is 105 degree. So, very straightforward. This is 75, this is also 75. So you can have B2, 180 minus 70, 180 minus 105, and you have 75 for angle AC prime B. Okay, so the first question is about sketching. Usually the second question follow-up will be finding the new angle. Okay, finding the new angle. Now we look at the third part, calculate the area in cm square of triangle AC prime B. So we look at the new triangle here. And we are required to find the area. So any area formula that you remember from this topic, right? You have 1 over 2 AB sine C. So the keyword here again is to find this angle. Which angle you want to rely on to find the area, and you know 50 here, you know this is 75, and this is 75, and how about this one? This will be 180 minus 150, you have 30 degree, this is 25. Okay, so together you know that this is 55 degree, and this is 4 cm. Do you know about this length AB? No, we know BC, we know DE. We have to find the length of AB first lah. Okay, now to make you back to see clearer, now what we have is A, C prime and B. We have to find the area. So the angle here, just now we know this is 55 degree. How do we know? This is 30 because this is 75, this is 75, and this is 25. So together you have 55 here. And this one 4 cm. So you just need to find the length of AB. You can put it into here, the formula. So now let's look at the length for AB. So to find that, we can have a look on the triangle ABC. ABC, so this is 105, this is 4. So we can use sine rule. 4 sine 50 equals to AB sine 105. So AB equals to 5.044. Okay, cm. This is 5.044. We have everything we need. Why? If this is angle C, this is small letter C, this is small letter A, this is small letter B. So you have 1/2, 4 and 5.044 sine 55 degree. And that would be the final answer. 0.5 multiplied by 4, so you have 2. .264 cm squared. Okay, that's the ambiguous case. You sketch it, you find a new angle, and you find the new area of the new shape. So a few things to take away. Ambiguous case usually you have isosceles triangle. And how do you know that question is about ambiguous? You have keyword sketching, and you have new point, C primes, and you have a conditions. So this is an ambiguous case. Now let's have a look on the following years and see what do we have for ambiguous case. 2010, 2011, not so much on ambiguous case, so we skip for now. And 2012. Okay, 2012, let's pay attention to these parts. Is it very similar? Point C lies on BE such that AC prime equals to AC. Sketch triangle, find new angle, calculate the area of new triangle. It is exactly the same, the way they ask. 2010 and 2012, same thing. Okay, so now we only look into this. So let's ignore this part for now. Let's focus on ambiguous case. So you have point C prime lines on BE. Okay, so we look at this one now. So we only look at part B, and part A assume that you have already found the answer. So A1 BC is 11.13, and AC is 6.23, and NCB is 53 degree, 53 minutes. Okay, assume you have the answer now. We look at part B. Okay, understand the question by itself. Point C prime, C, a new point again, C prime, lies on the line BC, okay, it's along this line, C prime, such that AC prime equals to AC, oh, okay, same thing again, AC prime equals to AC. Do you know the length of AC? Yes, you do now, 6.23, okay, so we are going to sketch another side of the triangle, which is AC prime. So it will be started from A, and you know that it will be a, okay, what is this? The keyword that I mentioned just now. This will be an isosceles triangle, right? Well done. This will be an isosceles triangle. Why? Because AC equals to AC prime, the length. So it has to be isosceles triangle. Okay, so this is your visualizations. So you need to sketch the triangle ABC prime. Okay, let's sketch it out. ABC prime. So you should be something like this. Okay, it should be something like this, right? C primes. Okay, let me change persistent. B, C prime, and also A. So this is a new shape. This is a new shape of ABC prime. And remember to put in the information that you know that will never change. Which one? AB, 9 cm. Okay, great. What else? 34 degree. And AC, 6.23. So just put in these ones. Okay. If you want to, okay, can. If you want to draw more, you can show like this also. Okay. And then you say that this is point C. and this is also 6.23. Okay, it's up to you if you want to have more of this. Okay, this is how you sketch it. And then we look at, again, find the new angle AC prime B. You need to find here AC prime B, you need to find here. And see what do we have. We know that ACB here is 5353. Okay, and this is an isosceles triangle. So this one will be also 53 degree 53 minutes. So is it possible to find this one? Yes, right? Straightforward. So you have B2 180 is a straight line angle minus 53 degree 53 minutes. 180 minus 53 minus 53, we will have 126.12. Okay, that is number 2, 126 or 12. Now we look at number 3. Calculate the area of the new triangle ABC prime. This one. Okay. Just now, what do we have? We have this angle 126.12. And this is 34 degrees. So is it possible to find this angle? Why this angle? Because I want this to be regarded as angle C, because you have side A and side B over here, so that we can apply this formula. Okay, so to find that one, that will be 180 minus 126.12 minus 34, and you have 19.88. Okay, you have 19.88. So you have 1 over 2, 9, 6.23, and sine 19.88 degree. And see what do we have for this one? 0.5 multiplied by 9 multiplied by 6.23 multiplied by sine 19.88. You should have 9.533 cm square for the area for AC prime B. Okay, and that's it for SPM 2012. Okay, let's continue to hunt for ambiguous case. 2013, do we have ambiguous case? Yes. Now pay attention on part B. Now the way of asking is different, but this is also the case of ambiguous. Okay, now let's have a look on the questions. The straight line PQ, this one, is extended. Extended. You have another keyword here. So another way of asking, extended. Do Q prime, new point, same thing, to Q prime, such that QR equals to Q prime R. This is still the same. Okay, this is still the same. So Q prime, so PQ extended until you have a Q prime. And we are very familiar with this already. What do we have if that's the case? We should have a isosceles triangle, right? PQ extended until you have Q prime here and QR equals to QR prime. So another isosceles triangle. Because you know that QR 5 cm will be equals to Q prime R 5 cm. So another isosceles triangle. Okay, so this is how you draw. Sketch the trapezium PQRS. Okay, now you're going to sketch everything. So you have to build a straight line PQ prime. So PQ primes, PS, SR, and RQ primes. Okay, doesn't look like it, huh? Okay, let's do again. Okay, P, S, R, Q prime. You can draw the line for RQ as well to show that you know that it's a different shapes. So this is Q, and put in the information that you know, 5 cm, 5 cm, and then this is 110, then this is 4 cm. Now you have another line here, P to R, 7 cm. Okay, this is how you sketch it. Now this time around, we are not sketching a triangle, a new triangle, but a new trapezium, but with the same concept, so same thing. Okay, so B1 done. We have to calculate the area for the triangle Q prime R. So we have to calculate this triangle. Okay, to calculate this triangle, look at what we have here. So far what we know is two of the side here. It is 5 cm. So this is 5, this will be 5 also. It will be best if we can find the angle here. Then we can calculate the area Q prime C. Is it possible? Okay, first look at the answer that we have first. A1 QPR, we should have how many? 44 degree 25 minutes. Line of PS 5.214. Now let's try to put this in. QPR. This is QPR. 44 degree 25 minutes. Oh, this is not QPR, I'm sorry. This is only QPR. 44 degree 25 minutes. Okay, what else do we know? The length of PS. So you have 5.214. Okay. Trapezium, there you go, you have your parallel lines. 4425. Okay. So we have to do a little bit of work lah. Look at this triangle. You have a pair of angle and a side that you know of. 5 cm give you 44 degree 35. So how about this one? 7 cm. Okay. So you have to apply sine rule. So we put sine RQP over 7 cm equals to sine 44 degree 25 minutes over 5 cm. And let's see what we have for RQP. Okay, and then shift sine inverse. You have 78.46, and when you look at this angle, does it look like an acute angle? No, right? This is an obtuse angle, right? So this should be 78 and 47 degree. Okay, this is Q1, this is Q2. Obtuse an angle, so that is 78.47, and this is also 78.47 degree. And this one, would you able to know? Yes, of course. 180 minus 23.06 degree. Okay, enough informations. We can do the area part. Huh? So area of triangle Q prime R equals to 1 over 2 AB. This is A, this is B, this is angle C. So 5 sine 23.06. 0.5 multiplied by 25 multiplied by sine 23.06. So your answer should be 4.896 cm squared. Okay, and that is the answer for SPM 2013's ambiguous case. Okay, we move on to SPM 2014's. Again, look at these parts. Sketch a triangle A prime, B prime, C prime, which have a different shapes. Again, different way of asking, but we know that this is the ambiguous case also. Now let's have a closer look. Let's have a closer look. Right. The keyword here again, B1, sketch. Okay, sketch a triangle is keyword here, meaning this is an ambiguous case. Sketch a triangle A prime, B prime, C prime, meaning you will have a different shape as compared to triangle ABC. So sketch is a keyword here, and a new point A prime, B prime, C prime is another keyword here. Different shape as well, and the information here. A prime, B prime equals to AB, A prime, C prime equals to AC. I know sometimes it will be a bit confusing when you look at this one. Always focus on the angle. Always focus on the angle. Only look at this one. Then you know how to sketch the triangle, the new triangle with different shapes. This angle remain the same. Angle A prime, B prime, C prime equals to angle ABC. Okay, so where is this angle? Okay, the ABC. So this angle remain the same, right? ABC, A prime, B prime, C prime, remain the same, 34 degree. So logically speaking, the two lines, AB and also BC, these two lines when they intersect, they form the degree of 34 degree, right? The value of 34 degree for the angle. So there are no way that you can adjust or you change the shape, the locations, the position of the line AB and BC, whether it's more inclining or it's more declining. There's no way that you can change it, because whenever you change it, the angle will be different. The angle will be different. So you cannot change it. Okay? AB and BC, it will be forever in these shapes. Okay? Because 34 degree is fixed. So AB and BC, that is the shapes. You cannot change it. If you change it, the angle will be different. Logical? Okay? So the only side of the triangle that you can play around, which one? Obviously, AC. Okay, you can move around with AC, and then you can play around and have a different shapes. Okay, so again, how long is AC? Because we know that AC prime equals to AC and AC equals to 5.8 cm. So we can play around with AC, and you know that AC prime will be something like this, because AC and AC primes, they are the same value, and this is an, again, what is this? Right, isosceles triangle. This is an isosceles triangle. Again, this is the case. Alright, okay, we need to sketch this out. Okay, so what do we need to know? is, let's say this is the case, this is C prime, and do you know the angle here? This angle would be 180 minus 101. Okay, sum of interior angle, and you should have 45 degree. This is 45, this will be 45 as well. This is 5.8, this is 5.8. Now this is what you have to know, right? And is there any more? Actually no more. Okay, let's sketch it out. So you have BC and also BA and also AC. Okay, look at this one. We are sketching A prime, B prime, C prime. So you no longer put B, but B prime. It's a different shapes. So you have to label as B prime in this case. And this one no longer A, but A prime. And this one C prime. And you have this never changed, 34. Do we know AB? No, we don't know. Do we know A prime, C prime? Yes, 5.8 cm. Okay, to be more precise, maybe you can continue sketching it on A prime C part. Okay, and you say this is C. And this is 45 degree. This will be 45 degree. This is 5.8 cm. And that's it. This is how you sketch the triangle. So this is B1. And now we look at B2. Hence state the size of B prime, A prime, C. Okay, so which one are you looking? BAC. We are looking for this angle. Okay, simple lah. We need to get this one. So this is 180 and 45. So this is 135. Am I right? Yes, 135. So to get B prime, A prime, C prime, you have 180 minus 135 minus 34. You should have 11s. So angle and that's it. Simple, right? Sketching and calculating a new angle. Okay, now this is 2014. Up until 2015, we still have the case of ambiguous. And in 2016, 17, 18, 19, there were no the case of ambiguous in the MX paper 2, and no one knows whether we will have ambiguous case in this coming SPM. Now it's always good to have more options. Now we have a look on these questions, SPM 2015. Of course, it's on the ambiguous case part B. Okay, look at this one. Sketch, another keyword for ambiguous. Sketch a triangle, a new triangle, S prime, Q prime, R prime, which has a different shapes from triangle SQL such that, okay, so you have a lot of information. But the most important information is you should look at this one first. Angle S prime, Q prime, R prime equals to SQR. Meaning this angle will not change from the old triangle, from the original triangle to the new shape of the triangle. This angle never change. SQR. Okay, which one? SQR, this is SQR, this part. Okay, when this angle never change, you will know that the side SQ and the side RQ, the positions will not be changing. If you change the positions, you open up the angle. You change the positions, the angle will be different. So SQ and QR basically is fixed. Is fixed. So the only side that we can play around is side SR. Okay? Side SR. Now, side SR, when you move you form an isosceles triangle, right? Forming an isosceles triangle, there could be two cases. This could be the case, isosceles triangle, or this one could be the case. Why? If I draw this one and I extend this line, it is still an isosceles triangle, right? So we do not know which one, case 1 or case 2. So now let's check on more information. Let's check on more information. The first information is SR prime equals to SR. The length is the same before and after the transformations. Before and after the transformations. Okay, not transformations. Before and after the change. S prime R prime equals to SR. Meaning this line you have the same after you change it. So, okay, it doesn't give us any hints whether we should draw like this or draw like this. That is not the deciding point to look at. And then we look at the second statement. S prime Q equals to SQ. Meaning this line is fixed. This line is fixed. Okay, we cannot shorten the length of it. Of course, the position is always there, but we cannot shorten the positions. Why? If I have isosceles triangle in this case, so this is my S prime. So try to measure here to here. This is my S prime Q prime. My S prime Q prime, after that, and my SQ, before that, the green and the red color line, the length is different. Different, right? So that could not be the case. You cannot draw an isosceles triangle here. So you should draw an isosceles triangle over here. And that is also 6 cm. Okay? And to make sure it makes sense, you have to extend the line. You have to extend the line of QR. Extend until you touches. And that is the shape. Okay, and now we draw it now. Okay, first we draw, this is R prime. We draw R prime Q. R prime, maybe this is R, and this is Q, and changing to Q prime also, and you should have S. So we have R prime S, maybe something like this. Okay, draw again. Isosceles triangle, so maybe it should be something like this. And then you have something like this. Change color, you can put dot lines. There you go. Isosceles triangle. It looks like an isosceles triangle. So you have S prime, R prime, R, and also Q prime. Is there any information that you know? This is 6 cm. What else do you know? Do you know the angle? No, we do not know the angle. And that's it. Maybe you know that RQ prime is 9 cm. And no more. QRS. Okay, just now, part A, you should have known some of the question here. Okay, now part A, let's look at the answer here. What is the length of QS? 14.19. QRS, 141 degree 22 minutes and 72.38 cm squared. So QRS here is 141 degree 22 minutes QRS. So meaning here you have 121 degree or 141, sorry, 141 degree 22 minutes. You can put it there, and that's how you sketch it up. And then now we look into part B. B2, hence state the size of SRQ, S prime R prime Q prime. We are looking for S prime R prime Q prime. We're looking for the angle here. Okay, simple also. This angle will be as the same angle with this one because this is an isosceles triangle and this is a straight line angle. So that would be angle S prime R prime Q prime equals to 180 straight line angle minus 141 degree 22 minutes. .63 degree is the final answer for the angle S prime R prime Q prime. Okay, so when you look at the ambiguous case, the way of being asked is different, but you identify several keywords here. 2015 ambiguous case, have a look on the keyword here. The keyword are sketch a triangle, S prime, Q prime, R prime, new point, different shapes or a keyword here from triangle such that from here to here, this will indicates this is an ambiguous case. You have to sketch a new shape with certain requirements. And hence, followed by calculated the angle. 2014, sketch a triangle A prime, B prime, C prime, which has a different shapes from triangle ABC and from here to here. Ambiguous case, new angle. 2013, the straight line PQ is extended to Q prime, a new point. QR equals to Q prime R. Ambiguous case, sketch the new shape, calculate the new area. 2012, point C lies on BE, BC such that AC prime equals to AC. So new point, new requirements, sketching the new shape, find a new angle, and find a new area. 2011, no ambiguous case. 2010, point C prime, new point, lines on BE such that AC prime equals to AC, sketch a new shape, find a new angle, find a new area. So from 2010 to 2015, except for 2011, 6 years. And among the 6 years, there are 5 ambiguous cases for 5 years. And do you think ambiguous case is important to be considered and to be studied for this coming SPM? Now for the year 2016 onwards, 2017, 18, 19, there will be no more ambiguous case. And what do we have? In the next lessons, I will talk about 2016. Now 2016 is different kind of question for solution of triangles. It is neither on ambiguous case, it is also not on 3 dimensions. Okay, and SPM 2017, as you can see, 3D objects 2017, and 2018 3D objects, and 2019 neither of the case. Okay, so in the next lesson I will talk more about the remaining topic for the solution of triangles. Thank you.